Good morning, Precalculus scholars. We are continuing with our Conic unit, and I just want you to know I appreciate all the hard work you guys have been doing, and overall I've been very pleased with how you guys have stepped up with what we've been doing. I'm just really going to ask you to ask questions, just looking over your quizzes, which I'll be emailing out within the next day. Number one thing, you have to show work. I can't give credit if you don't show work. Also, make sure if you don't understand something, call me at home. And let me give you this number again. It's 630-293-5917. I prefer if you call between 9 and 4 p.m. I will check messages about once in the evening. What I'm learning about myself with technology is I don't like being on it all day long. And so I am needing an ending point. So I try to finish between 4 and 5 every day and have a break. Just for the mental health, my own mental health, but also for my family. They don't need a stressed out mom around here as well. So today we are continuing, but I want to remind you a few things. Now, remember, we worked with circles first. Remember the standard form of a circle. And by the way, the symbol for a circle in geometry is a circle with a center point in it. So I'm going to use that, is the following. Quantity x minus h squared plus the quantity y minus k squared equals the radius squared, where your center is the ordered pair hk and your radius is obviously the square root of r squared. So making sure that we have those, and we used completing the square to help figure that out. So today we're working with parabolas. Now we've been calling them quadratics up to this point. Parabolas, guess what, are still quadratics. They have a definition, but a few things you need to know. One thing that we're not going to spend a lot of time with, but one that you know, is every parabola can be perfectly divided in half. And that division, or that line that divides it in half, is called the axis of symmetry. Now, what's more important for you to know is that every parabola has a vertex. That's where you either get your max or your min when you have a vertical parabola with it. And we use the points h and k with them just like before. And h is always going to be the x coordinate and k is always going to be the y coordinate. So please don't forget that when you're working with it. So like this ordered pair right here, that would be hk. It's at the origin, so it would actually be 0, 0 in this case. So those are kind of important things to do. But then we actually had a fancy definition for a parabola, and it said the following. A parabola is the fact that all points on a parabola are the same distance from a given line, and that given line is called the directrix. And a fixed point called your focus. Now, focus, if you remember when you worked with mirrors in physics, is always going to be in the interior of your parabola. And the cool thing is we always know that the vertex is going to be right in the middle. It's halfway between the two. So here's what I mean. Here's your focus. It's on the inside. Your directrix is going to be this line. The definition of a parabola is if I picked any point on this line and this line segment have to be the same length in order to be a parabola. We're not going to worry about the length of those lines, but we are going to worry about the following things. You need to know vertex, focus, and you have to know how to find the directrix and identify it. Also, you need to remember parabolas can look a lot of different ways, and we're actually going to have a couple different scenarios. Okay, so we're going to learn to change equations of parabolas into two different forms. So when we're working with that, we're still going to work with standard form. Now here's a few things about standard form you need to know. Standard form, we're always going to use the fact that the vertex is at hk. So don't forget your vertex right here. But we're also going to use the fact that we can draw parabolas on their sides, or we can draw them upside down, or we could draw it also to our left. And we're going to talk about those different scenarios and how to identify them. Now, the type of quadratic you guys have been working with the most is the very first example. And it is when you end up having a y term to the first degree and you have an x squared term. These are the ones where you have parabolas that open up or they open down. So we talk about the max and min when you work with it. Now, this lovely value out here in front of our quantity, it is actually kind of like the A, the amplitude or the vertical stretch. So this is where we get our vertical stretch from. And it lets you know if something opens up or not. So if it's positive, right? So if we have a positive, we know our parabola is going to open up. If it's a negative value, we know it's going to open down. So those are kind of a simple ones that we have. But then we also have parabolas that can open to the right or they can open to the left. So here's the cool thing. So if we open to the right, parabola looking this way, or to the left, notice the difference. This time your x is to a first degree, but your y, not sure why I hit that, but here, oops, still doing it again here for me. Your y, I'm gonna get my stuff back here. Love technology, you guys know how I love doing this. Okay. Our y is being squared. So our y term is the one that's being squared. But a few things you need to remember. Again, this value out in front of the parentheses tell me if I either open to the right or to the left. So if I'm positive, okay, so we have a positive value for the 1 over 4c, you are going to open to the right. If you have a negative value for this, you are going to open to the left when we're working with it. But also notice the difference here. My H and K switch spots. So it's going to be very important that you know which form you're working with. So you know if you open right, left, up, or down when you're working with these values. All right, a few things you need to know about parabolas that are huge. Okay. C, where did this value of C come from? We're just coming up and all of a sudden we're just throwing this little value of C in here, okay? Well, first of all, C is the distance from the vertex, so how far the vertex is to the focus. And it's the distance from the vertex to the directrix. And let me show you where I'm talking about for this. Okay. So this is the distance of C from here to here. It's how far away. So I either go up C, positive to the right or to the left, or up or down. So it's the C distance away. All right. We also want to know that the focus is always on the inside. There's no other way the focus works with a parabola but being on the inside. The term that is not squared, like the x or y, is where the direction the parabola is opening. So if x is not squared, you're opening left or right. If the y is not squared, you're opening up or down. The C value being positive or negative will also tell you if you're opening up or down as well, which really helps us. Now, I have a step-by-step kind of process for doing this. That will hopefully help you. But again, completing the square is going to be huge, but also just carefully watching the examples that I give you are helpful. And plus your textbook has very solid examples as well. Oh, by the way, I can't post the textbook page unless you own a textbook. And a few students openly said they didn't ever own the textbook, so I can't post that. So you're either going to have to borrow from one another, or you can email me and I can send it to you. But it's going to be very important that you still work with these. All right, so my friends, here we go. What are the steps of how to graph a parabola or find the steps on here? First of all, you have to get your equation in standard form. All right, so that's either going to be like x equals, like 1/5 y squared, or you're going to get like a y equals like say 2/3 x squared, something in that manner. But a few things you need to remember, fractions are going to be really huge. If you divide by something, it's the same thing as multiplying by its reciprocal. So that way we can find C easier. You got to decide if the parabola opens up or down or left, right, and that tells us. They say find the vertex and plot it in the coordinate plane. That's my number one thing I do is I always find the vertex. Drawing the axis of symmetry is okay, but I'm going to tell you right now, it's not life or death if you can plot just a couple points because it reflects over. determining the C value is huge because that helps us put a focus in and also helps us find the directrix. And then we draw the parabola. Now, I don't want you guys to get overly freaked out, like, oh, I don't know what I'm doing. Just trust me on this. It comes out pretty easy first. Okay, so let's start with the values. So remember, we're going to have two forms of this. We're going to have the following. We're going to get y equals 1 over 4c times the quantity x minus h squared plus k. Or we're going to have the form x equals 1 over 4c times the quantity y minus k squared plus h. And remember, h and k are the values of our vertex. So you have to be very careful when you're looking to see what form you're working with. All right, so let's look at the very first one. It says find the vertex, focus, and the directrix of the parabola given by y equals 1/2 x squared. So really this means y equals 1/2 times the quantity x squared. So looking at this, we got to decide which form is it. Is it the y equals or is it the x equals? Well, the cool thing is this is our y equals, so it's this format. Also, notice we have no numbers with this. So really, we're just going to rewrite this form down because this is the form we're using. We're going to plug the numbers in when we have nothing but the x squared. It really means the following. We have a 1/2 times quantity x minus 0 squared plus 0. So if you're looking at this, what is going to be your vertex? Now someone goes, where did the zeros come from? They're already there. Remember, if you go 1 plus 0, what's your value? 1. So the 0 can be there anyway. So this is our equation rewritten. So our vertex is at 0, 0. But we need to know C in order to start to do our quick graph, and we need to graph so we can find the focus and directrix when we're doing this. So vertex is going to be at 0, 0. This would have been your H, that would have been your K. Okay, so we go 1 over 4c is equal to 1/2. Notice we get a proportion. I would say for most of you, the best idea is to cross multiply and solve. So I get 4c is equal to 2, and I get c is equal to 2 divided by 4, which is equal to 1/2. Now it's a positive 1/2. So let's go to our graph here. We have our x. We have our y. Our vertex is at 0, 0, and it's a positive 1/2. So I know my parabola is opening up. Now, how do I find my focus? Well, you go to your vertex and you go either up, down, or right, left based off what you have. Since it's a positive 1/2, I go up 1/2. Notice the x value doesn't change, and that becomes 0 plus 1/2. So my focus, and remember this is adding c, is going to be 0 positive 1/2. Now, how do I find my directrix? Well, my directrix is in the opposite direction, so that's a negative 1/2, and that means I'm going to have, in this case, the directrix is a horizontal line, so it's y equals. We went down a negative 1/2, so my directrix is the line y equals a negative 1/2. So those are all the pieces of information I got from this parabola. Now, you should be able to pick those out pretty easy, but notice to get C, you're gonna want to use the idea of adding and subtracting the C to get your focus and directrix. It saves a lot of time. All right, so let's try the next one here. It says, find the standard form of the equation of a parabola with a vertex at 0, 0, and we have a focus at 0, -2. So let's just draw this because this gives us a good idea. So I have a vertex at 0, 0. So here's H and K. And it says our focus is at 0, -2. So here's our focus, which means my parabola is opening down. Okay, so focus is always on the inside of the parabola, so that's opening down. The cool thing is that tells us what our C value is. We had to go how far down from the vertex to get my focus? Well, I had to go down 2, so C is a -2. So that gave me, I went down -2. So that helps us find our values. Plus, this is opening down. So we're using this form of a parabola. Y equals 1 over 4c times the quantity x minus h squared plus k. Well, let's plug in all of our values. We get 1 over 4. C is a -2 because we went down in order to get our parabola. So we got here a -2. And then we go times the quantity. Well, what are h and k? They're 0. So minus 0 squared plus 0. And what do we get here? Y equals a -1/8 x squared. Because x minus 0 is x. And then we don't have to do the 0. So this would be the equation of this parabola. Notice I didn't have to worry about the directrix when I just draw it real roughly or actually write the equation. The directrix is just there with its definition to be able to help to graph a little bit. Okay, so those are the starts. I know this can be confusing. Another great resource is Khan Academy, or just go into YouTube and Google how to write you could say the equation of a parabola in Vertex form, or use Khan Academy or something like that to help you as well. All right, and then there's also a thing called a telephone, and I can help you guys as well with Zoom conferencing. It works out great. Now the next one says find the vertex, focus, and directrix of the parabola given, and we get an x squared minus 2x minus 16y equals minus 31 equals 0. All right, so let's just write this here because it's just like a pain that it's in its 2 separate lines. And what are the processes that I have to do? Now I'm going to write this process, and I think you guys are going to catch it pretty quick. First of all, what are we going to do? We're going to group. You look for what's being squared. So you just want to group that variable on one side. So we're going to group the x terms. All right. And move everything else to the other side. Move everything to the other side of the equation. Okay. And then you're going to complete the square. And then complete the square. All right. Now we're not going to do it all the way. Again, we're doing this so we can get our parentheses being squared. All right, then you are going to solve for y. So next up, you're going to solve for your y. And then the last thing you do is you're going to find c, and then you're going to use that to find your focus and your directrix. All right, so let's do this one together. I'm going to do this one in red. So let's keep our x values together. And we're going to keep our y's together. So here's what I'm going to do. I'm going to move everything I'm actually going to say to the left here. Here's what I'm going to show you. I'm going to go x squared minus 2x is going to equal right here a 16y plus 31. And I'm going to rewrite it this way. 16y plus 31 equals x squared plus 2x. I just rewrote it so that way y equals, it goes easier in the form that we're doing. But now we're going to be completing the square. Okay, so remember when we're completing the square, I did not want to change values for me. Well, let's do it this way then. We have to remember that when we go here x squared plus 2x, we're going to go plus 1. Okay, another thing is we always want the value in front of x to be a positive 1. So we try to get rid of stuff that would be in the way as well. But we got to remember we're going to add it to both sides when we're doing completing the square. So plus, plus. Then completing the square, we're going to look here at 2, and then we're going to divide that by 2. So 2 divided by 2 is 1. So, 2 divided by 2, let's see if this is going to write here today. 2 divided by 2 is 1. Nope, not going to look good. Squared would be 1. Okay, so I add it to both sides. So now I get 16y plus 32, and now we're going to write our x squared plus 2x plus 1 as a binomial squared. which gives us an x plus 1. Now we're going to take the time and we're going to solve for y. So first thing I'm going to do is I'm going to subtract the 32 over. Do not put it inside the parentheses. That's illegal math, plus we don't want to do that. So we get here 16y is equal to the quantity x plus 1 squared minus 32. Then we're going to divide everything by 16. What does that give us? Well, that gives us y equals, and I'm going to rewrite this, 1/16 times the quantity x plus 1 squared minus 2. Remember, I can rewrite this as a fraction, and you need to be able to do that so you can see it. So now we have this in standard form or vertex form of a parabola, or they call it the standard vertex form. So we should be able to pull out the cool information that helps us. So here's what we're going to do. First of all, we're going to get our vertex. So our vertex, remember, this would be h and this is k. Since that's a positive 1, that our vertex becomes out a -1, 2. Our focus and directrix we can't find unless we solve for c. So we're going to go 1/16 is equal to 1/4c. If you cross multiply, you get 4c is equal to 16. c is equal to 4. It's a positive 4. So we know if I did a rough graph of this parabola, its vertex is at a -1, 2. It's positive c, so, and since this is y equals, we're opening it up. And then we're going to take that c and we're going to add 4 onto our vertex. So my focus is really a -1, and we get 2 plus 4, right? Oops, you know what? I just realized I graphed that wrong, guys. Oh, this is where I need to get parabolas. Okay, here we go. It is going to be, excuse me, a -1. Make sure I got this one right. -2. I wrote my vertex wrong altogether. Here, -1, -2. Here we go. Now I got it right. Okay, we know it's opening up in some way, shape, or form. And c is a positive 4. So I got to count up 4. 1, 2, 3, 4. And that's going to be your focus. So our focus, make sure I do this one right because I had to add 4 onto it, is going to be at 1, positive 2, okay? Because we took our value for c, which you found to be 4, and I added it on going up. So this value was plus 4. Opening up, focus is inside, so it'd be at 1, 2. The directrix means I have to go the opposite direction for. So we got to go 1, 2, 3, 4 down. That's going to be a -c. And so that would end up being y equals a -6. So those are all the information we got. This would be our equation for the parabola, and this would be our focus and our vertex. Okay, so we have a couple more of these, so I know your mind is like hurting, but I know you guys can do these. We're going to do a couple that are opening to the right and to the left, and I think you guys should be able to get these down. All right, first things first. Here we wrote in everything you need to know, okay? So this time we have our y squared. So we are going to change it to this form, okay? We want it to look like the following. Y equals, make sure that's gone. Y equals 1/4c, right? Oops, I just did it the wrong way. Excuse me. X equals 1/4c times the quantity y minus k squared plus h. So we want to make sure that we are very careful with those when we're working with it, and we want to make sure it's in that format. So when I'm looking at this, I need to get x by itself, okay? I need to get x by itself. You could do this a couple different ways, and I'm good either way with this. For many of you, if you're solving for x, I would say the first thing you should do is divide by 4. Okay, so this is the form I want to get to. So I'm going to divide everything by 4. So I get y minus 2, that quantity is squared, and then really I'm multiplying it by 1/4. Why do I know it's 1/4? Remember, if I divide by a number, it's multiplying by the reciprocal. And I get left over here x minus 3. Well, I need to get x by itself if I'm doing this form. So we now have 1/4 times the quantity y minus 2 squared plus 3 is equal to x. So if you want to put the x on the other side so it makes a little more sense, please switch it. So we get x is equal to 1/4 the quantity y minus 2 squared plus 3. I just did let's call the symmetric property and just switch sides of our equation. And now I want you to look what you see here. I love the fact that these landed together. You should be able to pull out the vertex. Now be careful. Remember, this is your h this time. So what is your vertex? Your vertex is going to be at 3, positive 2, because it's minus k. So it's positive 2. Kind of cool, huh? Exactly. Now, what is your axis of symmetry? So we go here to 3, positive 2. So we go 3, positive 2 here. And we have to decide when it's opening, which way it's opening. Well, this is positive, so I know I'm going to be opening to the right. So it's going to look something like this. Your axis of symmetry is this line right here. So your axis of symmetry is going to be y is equal to 2. Not too bad, right? Then we are going to get your focus. Well, our focus, remember, is found using c. So I go 1/4 c is equal to 1/4. Guys, what does c have to equal? Yep, c has to equal a positive 1. So that means it has to go on the inside, okay? Which, if I'm going positive 1 from this, I'm going 1 to the right. This is C. That point is now my focus, which means I'm going to be at 4, 2. Now, someone goes, how do I know where to add it to the x or the y? This is when I think it's critical to draw the basic parabola. Even though I knew my parabola isn't going to be drawn to scale perfectly, it helps me know where my focus is supposed to be. So it lets me visually decide if I'm going right, left, or up, down. Obviously, if I'm opening to the right or left, I'm going to go right, left. But that means this is my focus, and my focus is going to be at 4, 2. Now, the directrix goes in the opposite direction. So I need to go 1 this direction back, so a -1. And then remember, it's a line. So I draw that line, and this time it's going to be at an x value. And this is going to be at x is equal to 2. So does that make a little bit more sense? Directrix is really hard to get, and so is focus. But if you can solve for C and you draw a rough graph of your parabola, the parabola is always going to tell you what you're doing. Now, how did I know to open right? Well, I looked here and I'm like, oh, I don't even know what C is yet, but it's positive, so I know I'm opening to the right. It kind of helps us know, like when we were doing this before. Okay, one last example. Again, knowing how to draw stuff goes a long ways. It says the following. It says, write the standard form of the equation of a parabola with a focus at 1, 2, and a directrix at x equals 3. So here I have a focus at 1, 2, so we're going to go 1, 2. Oops, I have my wrong values here. Okay. Focus is at 1, 2. And I have a directrix at x equals 3. So this is going to be my directrix. Now remember a couple things you need to remember. Remember, the vertex is halfway between the focus and the directrix, right? So with that, and guys, here's the thing. I'm going to tell you right now, we're going to kind of head slow through this, a little bit slower than what we were planning on. But if you draw and you know that it's halfway between, you know if this is the focus and it's halfway, this has to be your vertex value. So my vertex, because this from here to here is a 2 distance away, my vertex, well, it writes here real quick, is at what value? It is at 2, 2. Okay. what does that mean my C value is, right? Well, if the focus is going this way, that means I'm opening this direction, and then my C value is actually a -1 because I'm going to the left. So it helps me find my C value too, because it even tells me kind of the direction that I'm opening. Now I have everything to plug in, okay? So with this, since we're opening to the left, we're in this format. X equals 1 over 4c times the quantity y minus k squared plus h. Well, let's plug it in. Well, we know that c is going to be -1, so we got 1 over 4 times a -1. Put your parenthesis here. We also have the fact, here's our h and k. Okay, so with that, we're going to go y minus 2 squared, because this is k, plus 2. And then we'll just finish simplifying that. So it's a -1/4 times quantity y minus 2 squared plus 2. And that is the equation of the parabola, which has this focus and this directrix. Guys, I would have my OneNote on graph paper mode for all of these. It's going to make it simpler and be able to work with that. All right, I know this is kind of confusing. Take your time, maybe take notes, give a break, come back, do your homework, call. I will actually, let's just do this for your class, okay? At 3 p.m., okay, I'm going to have a Zoom meeting set up, okay? I will have a URL in your lesson, okay? So there'll be URL. You can click on that URL. It will bring you to the Zoom meeting. It might make you do a quick load of the app software, but it takes like 2 seconds. Just it will pop up at the bottom of your screen. Just say run or execute, say yes, and then you'll be able to come into a Zoom meeting, and we'll work some of the problems.